Operators and their types. Operators are nothing but special symbols that are used by the compiler to perform specific mathematical operations or logical manipulations. So we need some special symbols where compiler will understand what type of action must be taken in the given expression. There are some major types of operators and they are categorized for specific purposes. Let us see them one by one. Arithmetic operators. Arithmetic operators like plus, minus, multiply, divide, modulus, these symbols are used for basic arithmetical operations like addition, subtraction, multiplication, division and modulus. Relational operators. Relational operators are used for comparison, like if you want to compare two values, equal to, not equal to, greater than, less than equal to and greater than equal to are some operators which are used to compare values for the given variable or an expression. Logical operators. Logical operators like and, or, not are used to combine multiple results and give the true and false Boolean state for the given comparison. Bitwise operators like and, or, caret, these symbols are used for left shift, right shift and other purposes of bit manipulation. Assignment operators are used to assign value to a variable. For instance, if I say equals to, this equals to sign will be used to assign a value to a variable. Plus equals to, minus equals to, multiply equals to, divide equals to, mod equals to. These are shorthand expressions that can be used to shorten your expression but works in the similar way of calculating and assigning the value. Let us take a very simple example. Say a equals to 10 and I am saying a plus equals to a. Now here in this case the expression will be solved as a equals to a plus this value of a, which will be a equals to 10 plus 10 and the new value of a will be 20. You can also write in this expression as a equals to 10 and you are saying a minus equals to 5. Now in this case the expression will be solved as a equals to a minus 5, which will be 10 minus 5 and the new value of a will be 5, which is overwritten from 10. So these shorthand expressions are very useful when you are working in your programs. So this is how assignment operators work with arithmetic combinations. Increment and decrement operators like plus plus, minus minus, these variables increment and decrement operators like plus plus and minus minus, these operators are used to increment or decrement the value of current variable just by 1. So let us say I have a variable a with value 10 and I am saying a plus plus, so the value of a will become 11 only by 1. And if I say a minus minus and if I consider the value of a as 10, then in that case the value of a becomes 9. There are different modes of using this increment and decrement operators like pre-increment and post-increment. We will see it in further lectures. And another type of operator is conditional operator, also known as ternary operator, and it uses the combination of question mark and colon. It is used for conditional evaluation purpose. So these are main type of operators available in C: arithmetic, relational, logical, bitwise, assignment, increment or decrement operator, and conditional operators. Whenever we deal with operators, we need to know how does the precedence and associativity work. Precedence is nothing but giving priority to an operator. Now, we need to know if I am having multiple operators used in single expression, which operator will be given the highest priority and how can I gain the exact expected output or result after solving that expression. And associativity says in which direction the expression would be solved. Would be from left to right or from right to left. So, operator precedence. It defines the order in which operations are performed in an expression. So let us say an example, I have int result equals to 5 plus 3 into 2. Here it will evaluate 3 into 2, which is 6 first, and then this will be added with the number 5 and I'll get the result 11. Because star, which is multiplication sign, asterisk is having the higher priority as compared to plus sign or addition symbol. And associativity defines the direction in which the expression must be evaluated. Could be from left to right or right to left. So let us say I have an expression where I am having the operators of the same precedence. Then in that case, how it should work? So with an example, 5 minus 3 minus 1. As we see, both same operators are used. Minus here, first 5 minus 3 will be evaluated and then again minus 1 will be evaluated from the result. And hence, it is understood that it is executing from left to right. Not all operators execute from left to right. Let us see how the table of operators, precedence and associativity works. The high to low table specifies here that highest priority will be given to parenthesis, subscript operator, arrow and dot operators, and its associativity is from left to right. Then the priority is given to unary plus minus, plus plus, minus minus, not and tilde sign, which is the bitwise operator, and its execution of associativity is from right to left. Then comes the multiplication, division, modulus sign, where it will have left to right. Then comes addition and subtraction, again left to right, and later it comes with the assignment operator and again left to right. Then comes relational operators and logical operators. So initially this table is considered only for expression solving and how the symbols must be given higher or lower priority. When we deal with input-output statements in C, we are understanding the format specifiers are used in printf and scanf statements. So in previous lecture, I had explained you how %d format specifier is used to print the value for an integer variable. So let us see all different types of format specifiers where we are going to use all different types of basic data types to print or to get the result from the expression or even to get the value from the user. So in such scenarios where we have to directly use the value for a variable, we need format specifiers. Format specifiers define how data is presented in printf and scanf statement. Some of the common format specifiers are, for integer, it is %d or %i. For character, it is %c. For floating point, it is %f. For double type of a variable, you have to use %lf. For character array, which is a string, it is treated with %s. And for unsigned integer, you have to say %u. Even for memory addresses, %u works perfectly fine. Let us take an example here. If I have a value to print which is 10 here, I will use %d format specifier. as you can see here on the screen, integer, %d, double quotes close, comma. Make sure double quote is coming after %d and comma is coming after double quote. Now here the output would be integer colon. Now this %d is replaced with the value 10, which is shown here 10. Same way, if we want to print a character, as you can see a character A is to be printed, we are using %c format specifier, where character colon is the normal text. There's a space between colon and a % sign, so there's a space on the output also, and this %c is replaced with the character A and it is printing character colon space A. So this is how format specifiers help us to deal with the variables values to either print or to scan them. There are different types of input-output functions available in C library. They are categorized in two main types, formatted and unformatted. As we saw in the previous slide, we need format specifiers to print the value of a variable, so those types of functions come under formatted. As you can see, printf and scanf, because they need this format specifier mentioned to either print or to scan value from the user. So it allows the customization with format specifier or for structured data input or output. You can give specified data type for it. And when we talk about unformatted IO, you don't have to specify any of these format specifiers like %d, %u, %lf. None of them is needed. Directly use the function and pass an argument to it. However, we will see these few functions in the further chapters. So some of the unformatted IO functions are getchar if you want to accept a single character, putchar if you want to print a single character, getS if you want to accept a string from the user from console, and if you want to print the string to the console, you will have to use putS function. It directly reads or outputs the data without any of the format specifiers needed. So if we say an example char ch equal to getchar, I am going to put any of the letter on the output screen, no format specifier needed, and the value is directly given to ch. And if I want to print ch, I can say putchar. So this putchar function will directly take the letter from ch, whatever is the value, directly prints it on the screen. So these are two main types of IO functions, formatted and unformatted IO functions. Typecasting. Typecasting is another small but important concept in C. Typecasting is nothing but converting one data type into another to let the expression solve with a perfection. We don't want any data loss, or if we want to match our data type with the library functions, or we want to convert the current data type into a smaller or the larger range of the value. In that case, we need the typecasting feature from C. So typecasting is nothing but converting one data type into another implicitly or explicitly. Now why typecasting is needed? We might need data compatibility to perform operations between different data types, like if I want to add one integer and one float, or I want to divide a float from integer, then I want some decimal values and I want to treat it as a floating point value which is to be divided. Memory efficiency, where I might need to convert to smaller types if needed. Precision control, I do not want to have any of the data loss even after the fractional parts, so I need the entire result from the expression. An interface with libraries where it will match the data types whenever the library functions are getting called. So let us see how these typecasting can be achieved in C. So let us see the examples of implicit and explicit typecasting in the slide. Implicit typecasting is an automatic version of typecasting where the compiler internally understands and converts it from the smaller to a larger data type. Let us see a basic example here. if I have an integer variable num with value 10 and I have a float variable result and I want to add a floating point number with num, which is say num equals to I have an integer variable num with value 10, a float variable result, and I want to add an integer with a float 5.5. Let's say 10 plus 5.5. So ideally the result would be 15.5. Now in this case, as we have an integer who is holding a whole number and a floating point value 5.5. Now when we are going to add these numbers, it will be generating 15.5 and give it to the result variable 15.5. Now here num is implicitly converted to float only for this executable statement. Now ideally the expression is internally evaluated as 10.5 plus 5.5, and now this. So ideally the expression is evaluated as 10.0 plus 5.5. Now the result 15.5 is generated and given to the result variable. So this is implicit conversion done directly by the system. And explicit conversion is where it's a manual type of a conversion, where programmer itself says that I want to manually convert this data type to the specified data type which I am asking you to do. So let us take the another example. Float result equals to 5 by 2. Ideally 5 divided by 2 should result into 2.5, but if I directly say 5 divided by 2, it will either result into 2.0 or only 2. Now in this case result is held with the floating point variable, so it is going to store value as 2.0, but if it would have been int result, then the value would be 2. Now here there is a data loss of 0.5. So to avoid this data loss and to have the precision of the result, we will keep either numerator or denominator float. So only for this expression I am asking it to convert into a float type. Now here the expression becomes 5.0 divided by 2, which will give a complete division of 2.5 as a result to the result variable. This is called as explicit typecasting. So implicit typecasting is done automatically and explicit typecasting has to be done manually. Moving ahead, let us write a C program to accept a number from the user and print it. Based on all the concepts that we have learned from the previous chapter and this chapter, we will use few functions, format specifiers, header files, and understand the working of the program. So as I want to accept a number from the user, I will have to use a special function for it, and if I want to print it, I will use another special function. So let us begin here. Hash include stdio.h, where I am including a header file, standard input output header file in my current program. Int main, the control starts executing in this function. Main is always the entry point for it. Curly brackets pair space that the code which is enclosed in this should be executed. I am creating a number variable int number. So in memory, the value for number will be stored in some random location. So 2 bytes of memory is allotted here. Currently there is no value into it, or there could be a garbage value. Now we will discuss about garbage value in further classes. Then I am saying printf enter the number. So on output screen I am going to get only this message, enter a number. It is waiting for a user to enter the value. Let's say user is entering the value 500. This 500 value is taken from the user and stored at the address ampersand. This is an ampersand sign at the address of the number variable. So what is the location of the number variable? Go there and store this value 500. And after storing, I'm coming back here. So once the user has pressed enter key, this line is executed. Next print statement says you entered. So on output screen, I'll get a normal print message, you entered, colon, %d number, the value which was given by the user. So what is the value at number address? What is the value at the location of this number variable? 500. This 500 is replaced with this %d symbol and it will display you entered 500 on the output screen. So this is how plain, simple and clear instructions are written in the code, and it will execute exactly the way we want it. So I hope you understood the simple C program of accepting and printing a number. So let us summarize what we have understood and learned so far in this session. Operators are the symbols where every symbol has its own meaning and it will be executing into the expression when used. Precedence and associativity plays a very important role when we have an expression with multiple operators or similar type of operators to execute and evaluate in the correct result. Format specifiers are used to print and scan the values using printf, scanf functions. And formatted and unformatted IO functions are used to handle input-output statements in structured or unstructured ways, as we had seen. There are two main types of typecasting available, which are implicit and explicit, and typecasting is nothing but ensuring the compatibility and get the good precision level results from the expression. We have also demonstrated a simple C program just to accept and display the value from the user and handle it. I hope you understood this session thoroughly. Keep practicing. Thank you so much.